how do you feel about the current progress of Victory?
I mean, it was good to see that they got some of the message passing working. That was nice.
Okay. Okay.
I would have thought that gotten the rest working already. So after that meeting we had last week, I looked at the code a bit and I started implementing it as well. So I have
okay.
a version. I have a version of it which does the spatial matching and has got a you register IPs and all that kind of thing. So I was actually wondering whether I should pass that along to Victory and say, here is an example of, there's an example of the connector that you can use. This is an example of how you can use the dictionaries. And so then you can either build on top of that. That would be the one option, or you can use that as a guide for, for the code he and Anisia is working on.
Okay.
Well, I mean, or the other option is to guide him to get his system, or get the code that he's been working on, working with a matcher and passing the messages along and things like that.
Okay, I see. Okay. All right. So I mean, did you do that sort of independently, or based on his code base?
Yeah, so I kind of independently, I looked at what he had and figured out, and then I basically refactored his code to a large extent.
I see.
And then, yeah. Anyway.
All right. Okay. So, all right. So I think obviously there's still some I guess coding gap that currently exists, right, between okay. So Victory should be coming up, right?
He did send a message about post or reconvening tomorrow that he doesn't have much update, so I suspect he won't be coming this morning. Yeah, he said reconvene tomorrow morning.
Okay, I see. Okay, all right. So yeah, I guess the I think there is the key question of what are we expecting, or I guess in order for him to grow into like a fully qualified PhD.
Yes.
Yeah. What is really required, right? I mean, obviously, a PhD is not based on coding skill, right? I mean, that's for sure. But on the other hand, I mean, the question becomes, can you get away with getting a PhD, but like without much coding skill? That's all right. I think Victor is coming up. Okay. All right.
Victory.
So, hi, Victory.
Morning. How are you?
Good morning. Good. All right. So, Hermie and I were just having a chat, but I think we can let you update your progress first.
Yeah.
Before, okay.
So I sort of sent a message on the group. There's not a lot of updates on my side, and now I'm even struggling to open my studio. It's saying, and I think it uninstalled itself or something. But there's not a lot of update on my side. I'm still waiting for a response from my leader, but I'm thinking I might have to call in a favor from someone else from the connector perspective. I've also tried to play around with the connector myself, such that we're using the old what do you call it now? The old the connector class we created where there was a fake network and a real network, but now in the fake network to sort of allow for signals and slots, such that the connector handles the connection while the matching just does the matching only. I think the biggest question it raised though was the because we are using object and thread, such that there's this thing Anisia did where for every node that was created, it created a sort of object in thread, and that thread location was stored at the matcher layer. So in this application, I'm still trying to see, does that functionality, does it go into the matcher or does it go into the connector? My best guess it goes into the connector. But at the same time, I'm not 100% sure, because now it looks like the connector is doing quite a lot of things.
Are you talking about the functionality to match the ID with the matcher? I mean, the ID with the IP address.
No, I'm talking about the simulation part now, where there is. So for the simulation at the signal slot layer, the best the approach that was used was, these nodes are created, and these nodes were created as objects. Like every single node ID, ID1, ID2, ID3, every single one had an object in memory, and there was a sense of when we are sending messages to the signals or the slot, it is the specific object that's receiving the message, so that it's not like one big file processing 10 things. It's like, I think the only part that's not an object in memory is the matcher, or well, that we're not doing anything with. It is an object in memory, but we're not doing any real thing yet, because we're not scaling up yet. But I'm trying to, let me just I think I'm just gonna
are you able to show some screens to show what you're talking about?
Let me just share this. Something happened. I think my system updated, but now it's not. Okay. I'm just gonna use Spider. Sorry, just hold on. Pi. The latest one. Special pops up. Connect to test. Okay, sorry, just hold on. Just in directory. Code. Now what? Okay. So if you'll notice here, in this simulator, sorry, I'm gonna fix my Visual Studio Code. I think that I prefer that nowadays. But if you notice here, there's sort of a message that has been generated in the thread layer. This is just as a pop. This is like a initialized sort of thing, and it is this message that's been replaced by whatever we append to the node, right? But that's just like a placeholder. So when we go to the matcher receiver, right? If you notice here, there's like an object being stored here. This signal is more like an object signal. The idea is we're sort of referencing that. So the whole idea behind this lock is for every object that comes through, you're doing it one at a time. So this is literally, this is like a process that happens. This matching sequence happens for every single connected object in memory, right? I'm trying to see now. Is it the signals or the node? I think it's the node. Sorry, not the signal. The node, yeah. So there's the ID, which is ID1, and then there's the object. So if I print this, and I hope this prints. I remember the last time it didn't. Yes, there. If you look at that, so there's node 1. This is the object. This is the object location in memory. There's node 2. So
I think I have to make that slightly bigger.
Sorry.
Victory.
Sorry. Yeah.
That's better.
Yeah. So these are the node lists. So node 1, right? So that's an object in memory. They're all different unique identities with their IDs. And, in this receiver, the idea is for every node, for every, request received from each object, perform a sequence of, the matching sequence, which is, well, create your signal, and if you're a publisher, publish. If you're a subscriber, check, if you're a subscriber, save, and if you're a publisher, basically. And that was why this whole nodes thing was saved in the first place. I think it was a temporary workaround to simulation. And so now like this is fine, don't get me wrong. For example, I think everything is sort of stored, as you can see, 1, 2, 4, 5, including the publishers and the subscribers, and we can always make a workaround to only store subscribers. But now I'm trying to sort of see if this sort of stays here or if this should go to the network. Where's the network connector? I think I should probably change this file name as network, where we sort of put it in the fake network socket. I don't know if you get what I mean. Yeah. Notice that. Yeah.
So let me so the handle message, where is that being called?
Handle message. So that's just the class that we're just using for every node.
No, not message. Handle message. Where is that being called?
Sorry, just hold on. So I think this should be just hold on. Oh, sorry, hold on. So from what I gather, there's every connector is making reference to this message subclass of some sort, where this is how it's defined. Each node is defined by the following, right? And that's where if you notice here, there's the type, there's the location, and there's the payload. And then it sort of goes through to the receiver, and when it connects, basically it's receiving this whole structure. So
wait,
it is
so
at the
go back to receiver. There was a handle message there somewhere, not the definition of the code where the function is being called. Oh, node.connect self.handle message.
Yes. So let me see that there.
What happens in node.connect?
Oh, sorry, not connect. So that's where the connection basically happens, where it's connecting the what do you call it, the signal to the slot, I think, if I'm not mistaken. Or, well, the theoretical connection, and then the signal slot happens there. So in this case now, the connection that's happening is I'm connecting what's the word now? The receiver, or should I say the sender, which is the node. The node messages is being sent, and it's connecting to the matcher. So this is the matcher handling the connection. So when it connects, sorry.
Yeah. So that node.connect, can you go to that function?
Yeah. There.
Okay, so is that function the callback function that's going to be called once a message is received?
Yes. Yes.
Precisely. Okay.
Precisely.
So that's what happens. Okay, cool. So is that the callback function that's going to be called when by the matcher, in other words, or is that the callback function that's going to be called by any of the nodes?
Basically by the matcher at the moment, because this is just specific to the node, right? And the challenge with this is you can't really reuse this for, say, different type of node. For example, you would have to recreate this somewhere else. But then again, this is like a simulator, and if you notice, there's a whole signal, because this is all linked to the signals and the slots, and that's why it's a bit tricky. And this is basically the receive part. It's sort of handling the or
So
maybe
you've
what I can
okay, so okay, but it looks
sorry.
like you've got a okay. So if I look at your simulation code, what it looks like is you create a bunch of nodes, and then what you do is you make each one of the nodes connect to the matcher. But
To the
that
matcher, yeah.
basically in code, what it does is it says tells the matcher when you receive a message from message, run this, do this callback function to receive
Yeah.
the message. And then
Yes.
you have a thread, where your nodes in your system joins randomly, or
Yeah.
randomly then just sends messages to the matcher.
To the yeah, so more or less that. Yeah. So there's that thread where so for every node there's sort of a so this is being created, but at the same time this is being threaded at the so for every node there's a thread created here, or there's a thread generated with the the override sort of text or variables.
So
And
if you if you
sorry.
wanted to expand this to more than one matcher.
And so at the moment, for example, if you notice, the matcher doesn't have any sort of like structure in terms of the the, for example, location and connect. But in theory, or I'm guessing now, I could be wrong, but if we're gonna have multiple matches for simulation, what would have done, uh, copy and paste this and basically create a new matcher and sort of connect them sort of similarly, but then there would be this sort of layer. Where you send it, where it also has its own connect function, right? So it's not necessarily reusable. So the goal now is to sort of transfer this, this connect and maybe even send function, connect, send, receive, into like a different connector such that it can be reused by all the nodes. And it is sort of simpler with the network, because network is network. It's just like a standard procedure. But with the signal, I think it's the approach we're using is a bit rigid, and that's the.
So is what you're trying to do now basically creating a connector class that is like the singleton instance like we spoke yesterday, and then inside of that you will basically have this, you'll basically have the connect function, and then you'll from outside pass this callback function.
Yeah, precisely at the receiver, and that way at least every node sort of, whether it's a matcher or a subscriber, they should be able to reuse the same connector class. And the question then comes up as to what do I do? Well, I think I'm sure we'll figure it out, but it was more of a concern that where does these go? Those nodes that have been stored. I mean, technically they should be stored in the matcher, because
No, they should be stored in the simulation class. So basically you have something which says the simulation, and the simulation basically is the class which says I'm going to create all my nodes, I'm going to configure all my nodes, and I'm going to be the engine that decides, oh, this node decides to subscribe to an area or to subscribe to a channel. Oh, now this randomly another message now decides to publish a message to a channel or to a spatial area. So it's basically the thing which you can think about creates and configures all the nodes in your experiment, and also controls them, if you want to think about it like that. So there in the simulation you would have the thread where all your nodes are randomly decide to publish a message or to subscribe or something like that. So it doesn't have to know. I mean, all it has to know is that it needs to create a matcher and it needs to create a bunch of nodes, and then it has to ask and it probably has to create an object, which is the underlying network infrastructure, which is now your connector class. And then I would say that your nodes and your matchers would then, when they are created, they would need an instance of this connector class, so that when they say, I want to register, or I want to, I want to bind to the network, create a socket that can send and receive messages, that it can then tell the connector class, I'm node 1, my IP address is this, and if you want to, and this is my buffer or this is my queue for receiving messages or something like that. And then when it decides it's want to send a message to a different node, let's say the matcher, then it's got the matcher's ID. It says, okay, I want to send a message to this matcher. So then it would ask the connector class, what is the what is the receive buffer or the receive queue of the matcher, so that you can basically send the message, which is basically copying the message onto the receive buffer of the matcher. And then in your simulation, you should have something which every couple of milliseconds, or every regularly basically says, do my nodes have any messages that they've received that they need to process? So that's the one way of doing it, where you basically just, you wait a certain amount of time and then you just process or receive messages. And the other option, what you have, and I think that's actually what the signals and slots do, is that the moment a node receives a message, it immediately, calls its callback function and then processes the messages and does whatever the message handling callback function says it must do.
Okay.
Now I think that I think the thing that you have at the moment is that your signals and slots are sitting in your nodes. And now the question is, how do other nodes basically get a different
access.
Nodes? Yeah.
Okay.
How do they figure out what that is?
So you're basically saying, sorry, in terms of the objects, we should sort of have like this universal sort of dictionary of nodes.
Yes.
Where then each node, whether matcher or receiver or node, has access to this big dictionary, probably in the simulator.
Yeah. Well, or the connector, but the simulator. Yeah. I mean, whether it's in the simulator or the connector doesn't make that.
The connector. Oh yeah, it doesn't.
To me, but
as long as it's universal.
But the thing is, it's sitting outside of a node, because all a node actually has is its own receive queue, and it knows what its own ID is, and it must have some way of connecting to this universal networking communication infrastructure, so that it can send and receive messages.
All right.
I don't know if you have if you want to add something to that, Shinyu.
Okay. Actually, not directly, but something else. Okay. Which is something. Before Victor joined, Herman and I, we were having a discussion, and so Herman, you like to share about your implementation?
So when we had a meeting last week, Victory. I had a look at your code that you'd written, and I had some free time. It doesn't happen often, but so then I started to try and make sense of what you guys have done, and I started refactoring some of the code. So I haven't pushed anything to GitHub because I don't want to overwrite what you have. But I can share I'll share you can handle tar gzip files, or should I just zip it?
Herman works.
You can do a branch, you can do a
branch.
That's a very good idea. Sorry, I wasn't thinking there.
Just do it, just create a separate branch.
I'll do a branch and push it to the GitHub page then, or the GitHub repo basically. But it's basically implementation of a connector and a fake network, which does channel-based PubSub and which does the spatial-based PubSub. The biggest problem was actually figuring out how threading works in Python. I'm less impressed with how threading works in Python, but anyway.
Okay.
So Java's threading is better, but anyway.
Oh yeah, Node.js is much simpler.
Yeah. So anyway, so there is because the problem was this thing about having something sitting there and basically processing messages. But anyway, so I'll push that to the GitHub repo, and then you can have a look at that. But that's basically then you can see there's a simulator. There's a connector with a fake network inside of it. There's a node, there's a matcher, and then you can see how that's kind of, I think, what Shunyan and I was aiming towards. And then you can use that as a basis for either implementing the real UDP network or having more than one matcher and starting to figure out how to handle that case when you have more than one matcher.
All right.
But I'll push that.
Wow, that's awesome.
I'll push that now.
Yeah. Okay. All right. So Victory, essentially, you have gotten yourself a cheat sheet. Okay.
Yes.
To the implementation.
Exactly what it is.
Yes, but so use it well. But I guess the important thing, I was just thinking about this, is that I mean, I think we have to go back to like what this is really about. Okay. Which is we're trying to do some PhD level work, okay, and supposedly to do some novel research contribution, okay. In the space, and I personally would consider, okay, the main contributions will be in the design, okay, and in the explaining of the problem, okay, and why this is an important problem. But also in the design and implementation of a practical system, that sort of realize a potential solution, right? Okay. So I think that is the kind of the skills, you need to develop and sort of demonstrate at the end of all this, okay? Yeah. So, I mean, right now, this reference implementation that Herman has done, I think it can serve as a very good learning material. Okay.
Definitely.
But yeah, but I mean, the important thing to note is that somehow you still have to be able to, I think, at least to master the core concepts and the design, okay, of the system, and whether and I think the core things to demonstrate is that you will be able to show that you can design a solution to this research problem we're posing, right? Do you see what I'm saying? I mean, I think it would not make sense, okay, if it's Herman, who has created the solution, although we can provide feedback, and ideas. But I think it's important that you yourself to, create this solution, okay, that can address the, this scalable, decentralized spatial communication problem, okay. But obviously, that being said, along the way, I think it's fine that you get, whatever help you might need, in terms for you to gain that that knowledge, know-how, or mastery over, designing a solution. Okay.
Definitely.
Is that
I understand what you mean?
Okay. Yeah. So I mean, use it well. And okay, so for tomorrow, I think what I like to see is a working version, based on what you currently have.
Yeah.
Okay, but potentially you can refer to what Herman has done. Okay.
Yeah. Makes
so
sense.
Is that all right, Herman? I think I don't know, that kind of is my thoughts towards the question we started earlier.
All right. that's perfectly fine. It makes perfect sense. Thanks so
Herman,
much, Professor.
you're muted. You're muted.
Sorry. Yeah, that's fine with me. Yeah, that's a good idea. I'm pushing the branch just now.
Okay.
Oh,
Okay.
nice.
Great. Great. All
Thanks
right.
so much,
Yeah.
sir. I'm on
Okay.
the GitHub
So
page.
Victor, do work on that, and okay, I think maybe let's get this to a milestone. But also
Yes.
secondarily get Alida to on board to
Yes,
the broad process itself. Okay.
I'm gonna try maybe because she's not been online for a while, so I'm not 100% sure what's going on.
Okay. Okay. All right. So
I'm gonna
maybe
try
Herman, you can
Teams.
help us. I don't know if Herman
Yeah,
can see
I'll do that.
just to clarify what's the situation on Alida's part. Okay. Yeah.
Yeah, I'll contact her and see if I can find out what's going on.
Okay. Okay.
All right.
Yeah. Thanks. Okay. So I guess meanwhile, focus on getting the implementation work then. Okay.
All right. I'll do that.
Okay.
I'll do that.
Okay.
Thanks
All
so
right.
much,
All
Union.
right. Okay. All right. So yeah, talk to you tomorrow then. Okay. And
All right.
Well,
hope to see the new work. Okay. Working.
Amen.
All right. Okay. All right. Take care. Take care. Yeah.
Thanks so
Bye-bye.
much. You too.
Yeah.
Enjoy your day.
Bye. Yeah.
bye.